In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3-2. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 5, they give us this complex number here, -1 minus 4 multiplied by square root 5 I. And they don't say it as clear cut as most students would like, but what they're asking about here is the square root. They say the square root of this can be represented as in the form of x plus I times y. So to write that down another way, the square root of this can equal x plus yi. Basically solve this. Now the problem here, well, it's not really a problem. There's actually two ways to do this. One way, which I'm not going to do because they don't really want us to do it, and I guess actually I can't really do it either, is to use de Moivre's theorem. That is to change this into cosine and sine, the polar form, and use de Moivre's theorem to get it to the power of a half. We just have to multiply the angles by a half, then it's much easier to do. The problem with doing it that way is the answer we get, at least my calculator, some calculators can, the answer I get on my calculator will be in a decimal place, in a digital form instead of the exact form. So they want your answer to have like a square root in it. So that's one problem, that's out. Also, they give us a hint. They tell us by first forming a quartic equation. It's okay if you don't know what that means. Quadratic equation, so x squared, x and a number. Quartic equation or cubic equation would be an x to the power 3. Quartic is just x to the power 4. So that's going to appear in this, and it wouldn't appear using de Moivre's theorem. Okay, so this it's not an uncommon question. Square root of a complex number. There's always been two ways to do it. This is one of the ways. Let's jump right into it. How we do it, we just square both sides. That'll get rid of this big square root here first. -1, 4 times square root of 5i. On this side, we get x by x squared, x by y is xy, y by x is another xy. So we get two of them, 2xy, and they both have an I in it. Then we have y by y, that's y squared. We have I by I, that's I squared, which is also -1. So we get a -1. That's what squaring both sides looks like. The next thing we do is something we do in lots of parts of maths, but it's very common in complex numbers. We equate the like terms on either side. The real numbers on the left equal the real numbers on the right. Let's put it over to the side here. -1 on the left is the only real number, is equal to x squared is a real number, and so is -y squared. That's a real number. So we get this separate equation. Rather than this whole thing, we get this smaller one. But also it's true of the imaginary numbers. So -4 square root 5 is also equal to 2xy. 2xy. You could leave an I on both of these, but they cancel. I on both sides, divide both sides by I, it disappears. So from this, we get this, a simultaneous equation. There's two equations, two unknowns. We can solve this. We have x squared and y squared in one of them. So what we do is we take this term and rearrange it so we get something on its own. What have I got here? I've got x on its own. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. So I'm going to take this second term here. Oh, sorry, first 2 divides both sides. To that side. I'm going to take this x and put it on its own. Basically, I'm going to divide both sides by y. This side becomes -2 square root 5 divided by y. I've got x on its own. I'm going to put this x into this equation. Well, let's just do that right now. Minus 1 says minus 1 equals x squared. That becomes this squared. So that's minus by minus, a plus. 2 by 2 is a 4. Square root of 5 by square root of 5 is a 5. We take multiply now. Y by y is y squared. And then minus y squared is still there. Minus y squared. I've now got to an equation with just one unknown. Y squared. It's the only thing in this that I don't know. It looks very awkward to solve. Let's just play with it until hopefully it looks better. We'll put it up here. If I get rid of this dividing, if I get rid of this here, multiply everyone by this, which is y squared. Hopefully that'll fix that. Minus 1 by y squared is minus y squared. 4 by 5 is 20. Multiply this by y squared, it just cancels. It's gone. That's what we're doing. That's why we did it. Minus y squared by y squared is minus y to the power of 4. And this is what they told us we'd find. We'd find a quartic equation, something to the power of 4. Let's get everyone the same side and put them in descending orders. So we'll put y to the power of 4 first, then y squared next, then y to the power of 0, which is what number is. This is the next little leap. It comes up often in exams. We have a quadratic equation, but it doesn't look like it. So it's a quartic equation, but I can rewrite this as y squared minus y squared minus 20 equals 0. That's actually a quadratic equation with y squared being the variable in it. So let's try and solve that. First, a lot of students can just replace this y squared with some other letter. Can't use x, we have that, we have y. K, p is a common one. Replace y squared with p, we just get p squared minus p minus 20 equals 0. That helps a lot of students. Hopefully you don't need that though. I'll just try and solve this quadratic with y squared. How do we get y to the power of 4? Y squared by y squared. How do we get 20? 20 times 1, 2 times 10, 5 times 4. There are options. Which of those options will get a 1? 2 and 20? No. 2 and 10? No. 1 and 20? No. 5 and 4? That will work. They can get to 1 by 5 minus 4. Or in this case it's minus 1. So that will be 4 minus 5 plus 4 minus 5 will solve this. If you're not able to do these factorizations in your head, that's okay. Use the minus b formula. It'll take you an extra 1 or maybe 2 minutes. You'll get the same answer. And the answer we get out here is y squared is equal minus 4, or y squared is equal 5. It's tempting to throw this answer away straight away, and that is correct. But it's also tempting to say, hang on, square root of a minus number, that's an imaginary number, and we're in complex numbers, so maybe this is an okay answer. Maybe we get 4 answers here, two from this and 2 from that. The problem is at the very start of the question they told us that x and y are real. We already had the imaginary part here. This is a real number and a real number multiplied by I. So we know x and y have to be real. That means y squared cannot be a minus. So that one has to be thrown out. Our 2 answers here are y is equal plus or minus the square root of 5. With the magic of editing, I've cleared off a space here to let us solve for x. We have, I've rubbed out the thing I was going to use. We had x is equal to minus 2 square root of 5 over y. I now know what y is. That means x is equal to minus 2 square root of 5 over plus or minus the square root of 5. Square root of 5's cancel. You could just do this question out twice, but a minus divided by a plus or a minus just would get the opposite. So we'd have a minus or a plus 2. The order there is important. That means when I have a minus 2, here's x and y. When we have x being minus 2, y is plus square root of 5. So that's one of our answers, the x plus y. When x is plus 2, The y is minus square root of 5. So that's our two answers there. And that's question 5 completed. If you have any follow-up questions or you see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.